When a chest tube is inserted by a critical care physician, the system is stabilized by suturing. The problem begins with what happens next. Confusion can cause a patient to pull the tube out, leading to trauma and emergency reinsertion. And even during normal activity, the tubing can snag on equipment or doors, causing accidental dislodgement. To solve these issues, we first conducted ethnographic observations in UPMC's surgical trauma ICU to understand how tubes are placed, secured, and managed. From our observations and a bit of ideating, we identified two key design needs: a controlled breakaway zone and a reliable one-way valve. We first started by making low-resolution models using simple, low-cost materials like foam core to mimic the chest wall. These quick models let us test how the breakaway mechanism separated under different pulling forces before moving on to higher fidelity designs and higher resolution prototyping. We also prototyped a simple one-way valve mimicking vein mechanisms to test directional flow and basic function. With our concept established, we moved on to medium-resolution prototyping. Feedback from clinicians helped us adjust dimensions, usability, and safety features. We mapped out risks and hazards using this analysis to strengthen our design and prevent failure modes. Once core features were validated, we locked in our final design, capturing the finalized anchor system and breakaway tube for testing. Here you can see fillet tube system in action. Our breakaway connector attaches securely to the proximal section of the chest tube, adding a controlled failsafe point that prevents traumatic dislodgement. Integrated into the same piece is our one-way valve, which maintains directional airflow and protects the patient in the event of an accidental pull. Distally, the chest tube is stabilized with a stat-log style retention mechanism, reducing rotational and axial movement at the skin exit site. Finally, an adhesive dressing is placed over the insertion site to seal the wound, protect the tissue, and secure the entire system into place. Here you can see the fillet tube breakaway in real use scenarios. A strong tug from the patient causes only the distal piece to release. And when the tube snags on a doorway while walking, the breakaway lets go, protecting the patient. Sharing the prototype with clinicians helped validate our approach, confirming that the breakaway feature aligns with real clinical needs. As we move forward, our system will undergo comprehensive verification testing for sterility, mechanical force and breakaway testing, additional leak testing to validate airtight seals, and testing the one-way valve functionality. Thank you for watching. We're all very excited to see you at the Design Expo.